if you were wondering whether you should be doing foundation or higher, there are a few topics that you can do a little bit of studying and bump that grade up from what you would get on the foundation. And I think vectors is a good one. So this is worth 4 marks, which suggests it might be quite a complex vectors question. But from knowing very little about vectors, you will be able to get at least some of those marks. And that's, on the higher tier paper, getting a few more marks can make a big difference to the grade. Anyway, so P is the midpoint of FD. We can sort of see that on the diagram. I might just highlight that fact by highlighting that those two lines are equal. Q is the midpoint of DE. I've changed the colour, but the main thing is that I've changed the symbol. If I'd have used a single line there, I would be saying that I'd be saying that not only are these two equal, but this is equal to that, and that is not given to us in the question. We don't know that. So if you just know what that notation means, you are going to get some marks on vectors questions. So it's very little learning for a few easy marks. Vectors have a direction and a magnitude. So the direction is indicated by that arrow. F to D is going to be called triangle. I'm just going to put it to the side there because it's going to get a bit crowded. So that's vector A. I've underlined it because in printed text they'll use a bold font for vectors. You can't write bold with your handwriting, so give it a little squiggle under the letter. You wouldn't lose marks for not writing that little tilde underneath. Is it called a tilde? Anyway, and the other one is F to E. So F to E, that is vector B. Use vector method to prove that PQ is parallel to FE. So we're trying to prove that those two lines in red are parallel. Notice the different notation. PQ does not have an arrow over the top of it. So that means it's not talking about the vector from P to Q. It's talking about the line segment PQ, right? It doesn't make much difference what the difference is there, but it's not a vector, so it's sort of fixed in place. It is the line between these two particular points, whereas vector A is just an arrow that is the correct length and in the right direction. So if I move this vector over here, I should have moved the arrow as well, then it's still the vector A. Right, the vectors are not fixed in place. So that's the difference between those different notation. Now, how do we prove that PQ is parallel to FE? So here's where we just dive in and we just try and do some things with vectors, and we're probably going to pick up a few marks even if we don't get the right answer. If a vector is parallel to another vector, it will be a multiple of that vector. So again, thinking about if that was one of my vectors and that was the other one, so let's say this is vector C and this is 2C, they're parallel, and we can see that they're parallel because one is a multiple of the other. So what this question is really asking us, it's asking us to show that the vector PQ equals some multiple of FE. So that's what we're being asked to show. So again, that's not much you need to know, is it? We just need to know that a parallel vector is a multiple of the other vector, and we need to understand how we navigate this shape to produce new vectors. Now, let's have a look at PQ then. Now, vector PQ, we find by just taking a journey from P to Q. So if I go from P to Q, I could go directly there, but unfortunately we don't know anything about the vector that goes horizontally through this shape. So we could take a different route. We could go from P up to D, and then from D down to Q. That would be one way to find the vector PQ. Another way would be to go from P to F, then F to Q, or from P to F, then F to E, then E to Q. All of those different routes are going to produce the same vector. So we want to find a route that's going to use these two vectors. So we need it to use parts of this side and this side. So P to Q. Let's try P to D. And then D to Q. And we want everything in terms of A and B. Okay, so this is going to be the awkward part, isn't it? D to Q, we don't have a vector for D to Q. P to D, well, we were told in the question that that part is equal to that part. So P to D is just halfway along this side of the triangle. So it's half of A. DQ, we don't quite have enough information yet, but we're going to have to use the fact that this Q splits D and E in half, doesn't it? So D to Q is going to be a half times D to E. What is D to E? Well, if we want to take a journey from D to E that only uses vectors A and B, well, we can start at D and go this way, going backwards along A, and then along here, going forwards along B. So if we've gone backwards along A, that's minus A, and then we've gone forwards along B, so that's plus B. So that's B minus A. And there we have it. We've got an expression for P to Q that only uses A and B. That will be a half A minus a half A plus a half B. So it's just a half B. So PQ is a half B. Fantastic, we're done, aren't we? Because we already know that FE is just equal to 1B, isn't it? It's just equal to B. So PQ, the vector, is equal to a half times FE. So they are parallel. The route that you take, it's kind of irrelevant. What matters is the start point and the end point. If they're the same, the vectors are the same. So you get quite complicated looking questions that have lots and lots of lines in them. You don't always just get a triangle. But all you need to do is sort of trace around where we're going on our journey and note the beginning and the end, and that's your vector.